Okay, the other thing that we're going to look at modifying or changing about our equation is the intercept. So let me go back and write a couple different lines. So y equals x, we'll start off with y equals x plus 2, y equals x minus 3. Just kind of compare those graphs. Okay, so y equals x. This is going to go through, it's got a y-intercept of 0. So it's going to go through the origin, and it's got a slope of 1. So we just looked at that. So that means it's going to go up 1 over 1, up 1 over 1. It's going to have a nice flat look like that. X plus 2 has got a y-intercept of 2, and it still has that slope of 1. But the y-intercept of 2 means it's going to cross the y-axis at 2, and then it's going to go up 1 over 1, up 1 over 1. Okay, it should look like something we refer to as parallel lines. Y equals x minus 3 has a y-intercept of 3 and again a slope of 1. So it's going to cross the y-axis at negative 3. And then with the slope of 1, it's still going to go up 1 over 1, up 1 over 1. And again, as I compare these three lines, you can kind of see that the y-intercept, that last number, physically moves the line up or down, but it maintains the same direction about it. Okay, use the function below to write an equation that describes the rain depth at any time after a storm has begun. Use the equation to find the rain depth 4 hours after the storm has begun. Okay, so we need a couple of bits of information about our situation here. I need to know what the slope is, and I need to know the y-intercept, and then I can insert those numbers into the y equals mx plus b. And so we can actually get this information off of our graph. They actually were kind enough to tell us that the slope is 0.5. And I can look and see that it crosses the y-axis at 0. So our equation, and now that I see that we're doing this in time and rain depth in inches, so our equation then would be the rain depth equals 0.5 times the time. Okay, and then I can use this to make a prediction. So the rain depth of 4 hours would be 0.5 times 4, and 0.5 times 4 is just 2. So my prediction would be 2 inches based on this equation. Okay, so let's talk about a general strategy on how to write a linear equation given two data values. We'll kind of break this down into steps. Step 1, find the slope, which is that formula, y equals y2 minus y1 over x2 minus x1. Then we're going to substitute the slope into y equals mx plus b. With one of our points. And we're going to use that to solve for b, the y-intercept. And then we're going to use the slope from step 1 and the y-intercept from step 2. And we're just going to replace that into y equals mx plus b, where we have numbers in for m and b, and we have x and y just in terms of variables. Alright, up until 1850, humans used so little crude oil that we can call the amount 0. at least in comparison to the amount used at that time. By 1960, humans have used a total of 600 billion cubic meters of oil. Create a linear model that describes the world oil since 1850. Discuss the validity of the model. Okay, so let's talk about some data values then. So we're saying in 1850 we had 0, and in 1960 we're using 600 billion. Okay, so according to our process, we want to find the slope first. So slope would equal y2 minus y1 over x2 minus x1. Okay, so that's 600 on top, and this would be 110 in the denominator. And we can actually reduce that down a little bit. So we have, what, 60 over 11, and I can even go to a calculator and get a nice, let's see if I can get a nice decimal out of that. So 60 divided by 11, 5.45. So I'm going to go ahead and leave it at 60 over 11 for now, since I don't have a nice even decimal. Alright, step 2 is to find the y-intercept. Now I have 2 points to pick from. I'm going to pick the one that has the 0 in it. Usually that's a lot easier to work with. So 0 equals 60 over 11 times the 1850 plus b. Okay, and let's see. So I need 60 times 1850. So 60 times 1850 is that. So what is that? 111,000. Try dividing that by 11, see if it worked. It's not even. But that's okay. So I get 10. Sorry, that number was 10,090.9. 10,090.9 plus b. So b then, I'm sorry, so we're going to subtract off that number from both sides. And I get b to equal negative 10,090.9. I drop all zeros all over the place here. Okay, so step 3 is to put that into some sort of equation. So it's y equals 60 over 11 x minus 10,090.9 would be my general equation to estimate the number of the oil consumption in a given year.